So next step I think is to try to fire this up and see what happens. Since the last video, I just quickly configured this DS1232 chip. This is the chip that really does the delayed reset on my, basically for the entire system, but really for the processor's sake more than anything. And so I have just some options here as far as where I'm configuring the delay, where I'm configuring this signal that really helps reset the watchdog or not. As long as there's activity, it won't auto reset. If it fails to have activity, then it auto resets the system. Or if the voltage level drops too low, it auto resets the system. So that's all configured just with these jumpers that I have around it. So I've set those. And I have two options when I get into this that I'm going to have to pick one or the other for clock. Either I can use the clock that I'm generating out of one of these PSOCs, and that is the long-term intention, is that that will be my onboard clock. Or I can bring a clock signal into one of these pins, and that way I can control it externally. And that's what I'm going to do to start. And so I have the same board I've been using through many of my videos to do that. And so I'll end up just using this little board here that will give me a clock signal. And so I'll tap that in here in just a little bit. But maybe to start, I want to measure some things. So all of the soldering's been done. And what I kind of want to do is just check between, maybe the, positive or VCC and ground, what my resistance is. And as I'm looking at that, that's climbing up. So it's not a short, which is what I'm really trying to check for. So with the capacitance on this board, it looks like it ends up at about 506 ohms or so. So that seems okay. No big concerns with that. Maybe the next thing I'm going to want to do then is just get power brought in here and measure what voltage am I getting up here, and maybe measure a couple of these other spots. So I'm going to change my meter to measure voltage, and we'll do DC voltage here. And then my power supply, I'm using again banana plugs, so I'll bring those in. I'm just going to maybe slide this over here a little bit. Okay, and I'm going to set that to, let's just see what voltage I have this set at before I turn it on. And so it looks like I've got it at 5.01 volts, and I'm going to limit it to 1 amp. Okay, so 5.01 volt. 1 amp is what I'm going to turn this on at. And I guess we'll see, kind of call this the smoke test, see if I get anything that really jumps out as bad. And I do get a short on my output. So either I'm hitting the current limit, which I definitely should not be at 1 amp here, or I have something wrong here somewhere. So I'm going to have to track this down. Where am I getting something? Basically, it's dropping down to 3 volts, and my output is showing that it basically has some sort of a short circuit. So I need to see, do I have something backwards here or something else going on? Just a quick feel test, just to see if there's anything that just feels backwards or wrong there. And I guess it's possible it could be above that limit of 1 amp. Maybe let me turn that up just to see. Nope, so I'm still pulling too much. So there's something not good here. Let me see if I can figure out what that is. So I'm going to pull up my schematic. Okay, so that all seems to be looking okay. So I need to just figure out where am I getting some sort of a short here. And or something that's pulling way too much current at least. So I'm getting about a 0.5 amp draw. And so now I've got to figure out what's going on here. So I'm going to start by hooking up at the bottom of this first. So turning power off. I'm going to put in this first P-sock, which is probably my most critical one. And that might also be where my issue is. And nope, that looks okay. So then this P-sock here should be trying to populate my RAM. And that appears to be where I have the issue. So let me get this other one in just to make sure. Okay, so as it sits right here, I'm pulling 0.513 amps. So I think as some of this other signaling got put in, that's looking better. So something with this, and I need to check what I've got going on for the wiring here. Okay, so there's something that when I'm putting this in, it's causing the issue. And what I might do here is just open up that tool for that. And this again is what on my previous system I had on some separate temporary boards to copy this into RAM. And so I'm going to go open up that logic, and I think I might just set this back to something really basic that I am not using any of those signals or outputting anything. But this would be what I've had before. Let's do this. I might just make a new project, and I'm going to do an empty. Then I have something just really simple here. What I might do is just take the LED, which is this 2.1. And so I'm going to come over here and basically I can come out to my pins and I'm going to grab a digital output pin. If I go over to modify that pin, I can have it go to 2.1. Here. So that's my LED. I'm going to close that tab. Okay, so that should be my LED. Let's just do something like a simple little clock. And I'm going to hook a clock right up to that pin and set it up for something really slow. So I'll just do once a second. And I don't think the clock in this can be that precise, so it might scream at me when I go to build this, but let me just do a test real quick here and build that. And while it's doing that, I'm going to grab the programmer for it, which I actually have one sitting here. So yeah, it's just telling me that okay with that. That tolerance is a little too tight. That's fine. I'm not worried about it. And then I need to program this. So I need to get this into a USB port. So now I can go ahead and connect this up. Normally this is just physically connected when you buy these. You can snap them apart. And then I just put headers on so that I can, whenever I want, plug this programmer in. And just make sure I orient that correctly. And then I'll go ahead and put this on here. And I'll give it a second, and then I'm going to go ahead and do a program. Okay, so now I've got this LED just flashing roughly once per second, so that's good enough. But now the question is, if I put it in here and turn on the system, does my whole system still seem to have issues? And it does not. So, okay, so that's good. So at this point, I have the entire system on. I have it at 5.01 volts and I'm drawing 0.6 amps. So I know that I have an issue then. If I go back into this other workspace, quickly look at what am I getting on all of these signals right now as I run around this. So maybe I'll grab my scope here. Yeah, I'm just gonna connect into a ground pin. So I've got ground pins in different spots here, but this one is probably my closest. And I do have that scope pulled up here. And so I should be able to come in here, for example, and if I hit power, you can see that there. And let me... Okay, so now I can read that I've got my 5 volts when I check my VCC here. And now I'm just going to kind of run around and see, you know, starting up here physically is down here. So I've got, should have my 5 volts and then ground. And then I have a reset out, which right now shouldn't be doing anything. I really want to look at the inputs. So at the other end of this, I should have a ground. And then I should have a clock in, which right now I have no clock running. There should be a reset in. That's an active low. So let's see. Now you're seeing that oscillate because this DS1232 is probably constantly cycling. It's resetting the system because it's not getting a clock because I don't have the clock running. But that shouldn't be an issue here. All of these are output enables. If I come down to my LED, you should be able to see that cycle with the LED. That's actually on the board. That looks good. You know, there's a switch I'm not connecting to. So that all seems fine from what I'm seeing so far. So maybe what I will do here is turn this off. I'm going to connect this clock board over here so I can get a clock running and just simply tap that into this clock pin right here. And so with this, I'm going to set it. I'm going to go ahead and turn it on. And I'm going to set it to an auto clock. I'm going to use a slow 555 based timer, and I'm going to turn that timer down in speed. So I have a clock speed adjustment that I can make here. And let me, okay. So this is going to just simply be a clock coming into the system. And maybe I'll turn it up a little bit more in speed. I'll find, okay, something right there. So now I should be able to just check that I have a clock coming in. And if I look at pin 30, coming in, I've got that over here. So 30. Okay. Just adjusting my scope here a little bit. Okay, so that's the clock I now have coming into the system. So I do have a clock. And then if I've got that clock, then I would expect my reset should be a little happier. Good. Okay, so that's all seeming okay without the program running on this, what it's supposed to be doing. So I'm gonna have to just little by little add those in. So I'm going to pause the video here, do a little bit of troubleshooting. Okay, after a little bit of troubleshooting, I believe I've figured out what the issue was, and maybe for now at least it's maybe even a non-issue. What I was seeing was that this DS chip here, this DS1232 reset chip, I was questioning what I was sending from that over to the PSOC, because it seemed like when this PSOC was reading the appropriate reset signal, I was seeing that my power supply was showing overcurrent protection and dropping the voltage down to compensate for that. And I had it maybe at 1 amp at that point. And so I was trying to figure out what in the world was going on. I did think, well, maybe it's a bad DS1232, so I swapped that out. I verified and double checked a few different things up in this area as far as jumpers and where I'm generating which signal. Is it active high, active low for reset, getting it down to here. I did look at maybe changing the logic within this PSOC. I tried a couple of things and just really was seeing the pattern that anytime I was doing what should have been a working reset, I was drawing too much power. Well, I decided at some point just to try increasing the limit on my power supply. Maybe that 1.5 amp that I had tested was insufficient. Maybe there's just too much of a rush to get things powered up here. So that's what I did. I bumped it up to 2.5 amp. And right now I have it turned on and it's bringing power to this board. And then when I flip this switch, that's powering the rest of the board. And you can see at this point that I am running. I have this clock running. A couple of things that I'm looking for. Let me turn it off. When I first turn it on, this LED on this PSOC is lit when it is in reset mode. And while it's doing that, it's copying over the ROM to the RAM. So while that's lit, and it should be lit for about a second, this should get populated. So that timing looked about right. This, I'm going to assume at this point, should be populated, at least from what I'm seeing so far. And then right now it's doing the processor initialization. And then these two PSOCs, I have the LED, onboard LED, tied to address 19 on this one. And if I go over and just show you here, here's this first PSOC, and the LED pin is connected to A19. And on this other PSOC, PSOC number 2, the LED is connected to A2. And that just happens to be that those are pins I'm using, but it's a neat indicator. So if I see these flashing, that means A19 was active or A2 was active on the bus from the processor. And so the behavior I'm seeing, again, I'm going to turn it off and turn it on, is that initially they're fully lit, which would be expected as it's looking at address FFFFFFE. Those should be lit up. And then once it gets through that, then I can now see it's jumping to some other addresses because I'm seeing different addresses come through there. And that is a good sign. That means I'm seeing some activity, and none of that activity can happen unless this stuff, I think, pretty much made it through its reset. Doesn't guarantee me that my RAM is properly populated from ROM, but I will look into that later. But it seems like I'm getting activity, which is, in my mind, a good sign. Now, at some point it stops, and that could be because the processor didn't get to the point of reading something worth jumping to or working with. So I might still have other issues going on here. But at least that initial reset, I'm seeing the activity on these address lines. Now, if I'm seeing a really high initial power, and I didn't see that requirement when I was using my previous board, which I was using this same setup. So something's pulling more current up front than I think I should be pulling. And likely that's because of some sort of contention is my guess. And so that tells me that maybe these aren't getting populated quite right from the ROM. And I'm just going to have to do a little bit more debugging to see what's going on there. And again, I think if I can get one of my debug cards to a PC up and running, that'll kind of help me see what is it reading for data when the processor is trying to really initialize and start running. because again, it seems like this is going through what seems like a normal type of behavior. This right now, processor's going through its initialization, and then I should see that, again, I see that activity. So all that behavior seems to be going through okay. Maybe if I go back to my scope for a second, let's see if I've still got this connected. Yeah, I do. So, what I could be looking at are a few things as far as those RAM chips are concerned. If I jump over to my schematic and look at the setup for this, I am creating some signals for these RAM write enables, and what I could do is see up front when it comes to my RAM, those write enable signals are going to go to these pins, basically 29. So pin 29 on the 4 different chips. So that's 1, 2, 3, 4 in. So if I just pick one of these, this is RAM, well, let's say RAM 3, 1, 2, 3, 4. And then I might turn off and turn on the system. Normal for a second, and when I flip this on, there you see all that activity. So let me just look at that, and I can see that when it booted up, it did go through for that chip all of those different writes. So that seems like a good sign. And if I come back over here, maybe I go to the next one over. Again, 4 down, and I'll just go ahead and turn off and turn on. Same type of thing, looking good. I'll just check this chip. Yep. And then this one here. And yeah, so I'm getting those separate write signals. That seems to be okay. And then of course later it's going to be trying to use the output enables. So I need to grab this pin 24. Processor is going through its reset, and now I can start to see some activity. I'm seeing that on my scope. It's showing it's getting triggered. So I'm going to see if I can slow down the acquisition here. Yeah, there we go. So that would be output of my RAM. That signal is getting through. So that is good. Okay, so, I'm seeing activity. And then the question is, do I have good data here? And I'm not going to really be able to do that with my scope. I only have a 4-channel scope. And to really tell what's going on data-wise, that's where I'm going to go back and get this board connected back in, and then get that address pulled off of here and the data signals pulled off of here. So I'll have to come back to that. Okay, so right now I am outputting 5.1 volts out of my power supply into this. This is reading 5 volts on here as I look at it. If I go back and I don't have my scope software running still, but if I just look at voltage real quick, by the time I'm getting over here, that's coming in through this little cable. I'm at 4.94. And then if I come way down here, yeah, 4.935. And if I pick something in the middle, kind of a worst case type of thing, maybe this chip right here, 4.91. Now I'm losing some because I'm going through this board for power distribution. So maybe if I want, I could rearrange this real quick again and have power come into this board, and then have this board, this jumper out, go to the input side of this little board I've got, which is just in this area. And then I've got a relay and a switch and all that. So I'll just leave this board on, or I can bypass all of that and just plug this into something beyond. There's just a box right here. So this right here should get it directly. Let's get this untangled a bit. But this should get it directly pulled into the board after the relay and everything and the switch. So it won't matter what I have that switch on or off, it won't matter. And let me go ahead and turn the system on again. Okay, so 5.1 is coming out. You can see now once it gets over here, it's 5.04. So I'm losing less in this way, going to this board first. And then I'll just double check what did I get down here. And that's a 5.04. So the voltage I'm getting here is matching what this board is seeing. So 5.1, I'm going through about a 3-foot cable to get to the board. And then from there, it seems like it's pretty comparable. So it should be fine for power. And again, this is running. So I'm going to call this a good enough spot for now. What I really need to do next is get this debug port and maybe the others here up and running, connected to a debugger that goes to my PC so that I can really read the addresses and data and signals as the system boots up, just to see what's not looking right. You know, do I have something, you know, is this getting populated properly is the first question. And then do I have any other control signals that aren't quite right? And that definitely could be the case. You know, again, going back to this board, you know, I had made a lot of design changes as I was going through it, and I'm usually pretty good about updating the schematic as soon as I physically make a modification. But there is a decent chance that I missed some stuff. And there's some stuff I don't have populated yet. I don't have some of these types of resistors and things on the bus, so I'm going to have to start looking at how clean the bus looks. You know, if I look at this right now, let me grab my scope. You know, if I come in and let's just say I'm looking at this RAM, which, you know, it's running right now, and RAM wise, if I want to grab like a data line, you know, I can come down here to pin 17, 18, 19. So let me just grab. And if I go back here and I'm looking at that, you know, I'm seeing some lower voltages and some higher voltages. So that could be just the flavor of chips I'm using and what's writing, but not concerned with this at all yet. So it seems like that data is coming out fine. Same over here. Let me grab a different pin on this one. Same thing. And one more up here. Okay, so those seem fine. And what I might be getting for differences in some of those voltages could be, again, the family of chips I'm using. And I might have a little bit of work to do there, but that'll be part of the fun here. And interestingly, this is still running. I've had this running for a while, and it's still showing activity. So it's happier about something, whether that's the minor power change I made, getting a little bit higher voltage over here as I went this route versus it was a little low before. So that is maybe even a better indicator. I'm seeing continued activity. It's not stopping. And the way I had written the code, the sample code that I had used from the last test board, is I'm using the same ROM. I haven't changed any code. It should be just running a loop where it's doing some basic register and memory type of writes, reads. So stopping there, I don't think I'll have any further updates for a week or two. I've got some travel coming up and won't have a chance to really look at much of this. I'm going to call that a win for now. So thanks for watching, and more to come in a week, maybe 2 weeks.